Alright guys, on this one, this is another circular motion problem. What would happen if I had a roller coaster, let's say, and this is the track, and it comes in and it wants to do a loop? Alright, how would I know whether or not the speed that I had it going into this loop at would allow it to complete the track? Okay, well, let's say that this loop has a radius of 20 meters. Okay, also pretend that I can actually draw and that this is a circle and not some kind of weird triangular circle ovoid thing. Alright, so 20 meters is our radius. Alright, so we got 20 meters as our radius, and let's just say that the roller coaster has a total mass of 5,000 kilograms. Okay, it's got a big mass. It's got to be 20 meters. Alright, it's got to go in a circle that's got a radius of 20 meters. Well, the very minimum amount that it could possibly have would be at this point, the only force acting on it was the force of gravity. If the only force acting on it at that point is the force of gravity, then it keeps in the circle. But normally if it's going in the circle, right, there's going to be a force of gravity and there's going to be a little bit of a normal force coming down from the track in order to keep it in the circle. So under normal circumstances, the centripetal force is equal to the force of gravity plus the normal force at that point. The minimum, the absolute minimum that you could have and have the thing stay in a circle would be if the centripetal force equaled the force of gravity and the normal force went to 0. That's the absolute minimum amount that would keep it in the circle. If it's any, if the centripetal force is less than the force of gravity is just going to pull it down and it's going to fall. And if the centripetal force is more than the force of gravity, then that normal force kicks in. So this is the absolute minimum. So if I'm trying to figure out the minimum speed in which to keep it going in the circle, then I have to set the centripetal force equal to the force of gravity. Well, if you'll remember, force of gravity is equal to mass times 10, so 5,000 times 10 is 50,000 newtons. So that's my force of gravity. It's also my centripetal force. Okay? So now, what we have to do is we have to do the centripetal force formula to figure out the minimum speed at which this could happen. So the centripetal force is equal to mv squared divided by r, and so the centripetal force then is equal to 50,000 newtons equals mass, which is 5,000 kilograms, v squared, divided by the radius, which is 20 meters. Okay, so I multiply 20 up and I get 1 million, I believe. Yes. 1 million. Okay. 1 million equals 5,000 v squared. Then I divide by 5,000 and I get 200 equals v squared. And then I have to do the square root. And so I get 14.1 meters per second equals v squared. And that would make sure, if this was going 14.1 meters per second squared, it would ensure that the roller coaster stayed in a circle. Alright? That would be the absolute minimum speed. Now let's just say that minimum, I can't spell minimum, so we'll just say the least speed. Alright, the least speed it could possibly have. Alright, let's just say that we needed to figure out the velocity, what the centripetal force would need to be if we had any other velocity. Or then rather than solve for the velocity, we would just plug it in. So for instance, what would be the centripetal force if it was going at 30 meters per second? Like let's say you needed to make sure that normal force on the roller coaster was able to withstand it. Well, then you could just do centripetal force equals 5,000 times 20 squared divided by 20, and you could figure it out for the speed of 20 meters per second. If we needed to, you could type this in, and you would get that the minimum speed needed would be, or the minimum force needed, the centripetal force needed would be a minimum of 100,000 newtons. Okay, So you can just plug that number in real quick. This is the important part here, is finding the minimum. This is the important part right here. Finding the minimum speed or the least speed it would be necessary in order to maintain the force of gravity. Okay, be awesome.